So thanks for that introduction. And as mentioned, I'm a relatively new faculty member. I'm about a year and a half in as an assistant research professor at Kansas State University. And this was actually one of the first projects I got to hop onto and help the team with. So I'm really excited to be here today and really get to present from the Kansas State University side what aspects of this project we had worked on. And really, we're going to focus on in this presentation the nutrition side, as well as some of the aspects from pig production and how we can essentially make those more efficient so that we're ultimately positively contributing to that entire cycle that Laura presented on in the introduction. And so one of the first objectives that we had was really to do a review that was aimed at summarizing practices to improve feed and nutrient utilization by pigs. And this was really so that we can get some concrete values for some of these nutritional or production strategies that could be then used in LCA. And so a picture here is Ron Navalis, our PhD student, and he really spearheaded this specific project. And really, when we're looking at this review that we conducted, as I'd mentioned, we really focused on that feeding component and that pig production component. And so when we looked at that, we really were able to break it down into 5 categories. And so we have diet nutrient levels, feed formulation, feed processing, feeding management. And then, although not nutrition focused, it does have a big impact. So we also have a category with things such as genetics, environment, and health. And so we do have a figure here, a flow chart that was adapted from Van Kempen and Van Houten in 2000 that really shows an overview of the flow of nutrients. So at the top of this flow diagram, we can see these boxes that represent some of that nutrient input. And then below these arrows, we see some of the boxes, specifically in this purple bar, and this would highlight some of the nutrient outflow or some of our inefficiencies. And so, for example, just to walk you through how this diagram works, at this first stage, it's simply providing that feed to the pig, and then we're going to have the pig consume some of that feed, so that feed intake. But inherently, we're going to have some feed wastage as part of that process. And so that would be an area of inefficiency. And we can see that these 2 colored circles down here actually correspond up in this corner with different of those 5 categories we broke this review down into. And so we can see that we actually can help manage feed wastage through aspects such as feeding management, which would be corresponding with the blue circle. Additionally, then taking it a step further, we see that we have that feed intake. And then when the pig consumes the feed, some of those nutrients are going to be absorbed. And so, however, even though they're absorbed nutrients, we do have some inefficiencies where things are undigested or we have some secretions. And so we also have aspects that affect that part of the overall flow diagram, such as nutrient diet levels, feed formulation, feed processing. Then we can look over here where once we have the nutrients absorbed, we have some of those nutrients available for growth. However, we can actually view some of those nutrients used as maintenance as an inefficiency as well. And we can see that can be impacted from anything from genetics, from environment, all the way to health. And so this is really just to set up some of these different categories that we looked at. And I want to cover today some of the main things that we saw that can impact the efficiencies throughout the pig production system. Now, I can't cover every single program that ultimately impacts nutrition or pig production, so I'll highlight some of these here, but we do have a further breakdown in a paper that I'll have linked at the end of this presentation. But one main aspect when we're thinking about nutrient levels is that we can think about nitrogen excretion. And so this is really related to the level of dietary crude protein. And what we found through different research studies is that we can have about an 8% reduction in our nitrogen excretion for every percent reduction that we have in crude protein. And so this is really related to the fact that we have these intact proteins, and if we can have synthetic amino acids replace those, maybe we're better able to meet that pig's requirement without having excess nitrogen. However, we do have to note, and some of the research we've been focusing on is we also have to be conscious of that SID lysine to crude protein ratio. So we do want to reduce crude protein so we're not excreting nitrogen, but if we take it too far, we might actually reduce the ability of that pig to develop muscle, and then we're getting an inefficiency in a different direction. We can also think of phosphorus as another major nutrient that we think about when we think about excretion. And so I have diagrams here, both from growing pigs and sows. And what we have represented is, if you look at this top diagram, would be the phosphorus excreted in feces. And what we see here is as we increase the amount of phosphorus intake, we get this linear increase in the amount of phosphorus excreted. However, when we look at the phosphorus excreted in the urine, we see a little bit of a different story where when we're closer to the pig's requirement, we don't see much phosphorus actually excreted in the urine. However, as we increase that phosphorus level above the pig's requirement, we see this exponential increase in our phosphorus excretion. We see this similar story in sows. Again, when we're closer to that animal's requirement, we're excreting less of that nutrient in urine or in feces. However, as we get above that requirement, we begin to see more of that excretion. So we can really think about meeting the animal's requirement, which is necessary, but if we go too far above that, that's one of the things that begin to lead to some of these impacts through excretion. Another way we can think about this is not just as individual nutrients, but as a diet altogether. And so we've been looking at, and the same student who conducted this review, Ron Navalis, also conducted a study looking at phase feeding versus diet blending. And so essentially we just compared to feeding one diet throughout a phase, or if we can blend that diet to more closely meet that animal's requirements at all different types of body weights. And what we did see is we got an improvement in our feed efficiency when we utilized that diet blending strategy. Now, we don't only see that in growing finishing pigs, we can also see that in sows. And another student here, as part of our Kansas State swine nutrition team, PhD student Michaela Spindler, conducted a similar study, again looking at phase feeding. And so this purple bar would be related to just having one lactation diet throughout that entire lactation period versus testing two different types of blending strategies. So rather that be a static or a dynamic precision feeding strategy. And very similar to what we saw in the growing finishing pigs, we were able to reduce their nitrogen intake by better meeting that animal's need throughout the entire lactation period, which ultimately resulted in a reduced nitrogen excretion. Now, when moving on to how we can formulate the diet, now that we've talked a little bit about the individual ingredients, one thing that's very common that people look at are feed additives. And so a student conducted a large meta-analysis looking at all types of feed additives in growing finishing pigs, specifically in their impact on feed efficiency. So how can we improve the efficiency during the growing finishing period when those pigs are consuming the most feed? And we can see here in this figure that there's all types of studies, and we grouped them by whether they had this positive, significant response to the feed additive, all the way to the other extreme, which would be a negative, significant response to the feed additive. And what we see in this review is that there were quite a few feed additives that came to the top as, in general, providing a positive response. And so all of these underlined in purple would have improved the feed efficiency by about 2.5%. Then, if we can sort these out a little bit more by what has the most research behind them, the largest number of peer-reviewed studies, we see that really 4 of these sort their way to the top. And so ultimately, what we were aiming to do with this study is provide producers with the most reliable data on feed additives that could potentially improve the efficiency during the growing finishing period. Now, another component, although it's widely known that how we process feed can impact feed efficiency and feed wastage, I think a lot of times we're thinking so much about the formulation that we forget about things like grinding and pelleting. And so this is just a representation of how that can impact feed efficiency. And so when looking at meal feed, as we reduce for every about 100 micron reduction in particle size, we can see anywhere from a 1 to 1.2% improvement in feed efficiency. We can also compound that with pelleting. And so when we actually utilize pelleting, we can see up to an 8% increase in feed efficiency just by pelleting that feed. When we combine that then also with particle size, we can see here within the pellet, we actually can even get an additional response by having a reduced particle size with that pellet. However, we do see a plateau when you start to go below 500 microns within the pellet. Now, there's also some general feeding management strategies that we can utilize to reduce feed wastage. And so just at a little bit connected to what I just presented on, which is diet presentation. So pelleting not only can improve that feed efficiency, as I'd mentioned, by up to 8%, it can actually help reduce feed wastage up to 5%. And so when we combine that, that can definitely have an impact when we're thinking about developing this LCA. Additionally, feeder types can help reduce feed wastage and improve feed efficiency. Unfortunately, there's not a lot of literature on different feeder types, and so this is definitely an area we could do more research on and have identified as being an area where we probably need to look into a little bit more to get some concrete numbers behind it. Finally, we do have pan coverage as well. And so something as simple as managing the pan coverage within the barn to be between 40 to 60% can help improve feed efficiency by reducing the amount of feed that's wasted by about 2.9%. So just a simple management strategy can go a long way with helping ultimately improve our efficiency and reduce the environmental impact. Now, although our team's really focused on nutritional strategies, we do have to admit that non-nutritional strategies play a huge role in the efficiency of a production system. And one of those is health status. And so we can actually see a huge difference in the efficiency of the pig based on their health status. When looking at gain to feed, if we look at this purple bar, that would be our control, so a presumed healthy herd of pigs. And then we can see a pretty drastic reduction in our efficiency if those pigs either have PRRS, PED, or we have a compounding effect when we had both PRRS and PED. Then we, in addition to that worsening of the feed efficiency, we can also see that we are reducing the digestibility of our nitrogen, ultimately with the worst performing group being that had both the PRRS and PED. So today, for the sake of time, I just went over some really high level factors that impact the efficiency of a pork production system. However, there's so many more aspects that also go into looking at the efficiency of the system for an LCA. So this can be anywhere from diet energy level to ingredient selection or use of enzymes. And so we have summarized all of that into a review, which I put a screenshot here, but it's published as part of the Journal of Animal Science. And so that will have some additional information and all of the citations looking through diet nutrient levels, feed formulation, feed processing, feeding management. And so I would encourage you to look at this review as well if this is something that you would like to learn more about or get some more specific information on. Now, I do want to transition into the second objective our team worked on. And in that first objective, I talked a little bit about nutrient excretion. And one of the nutrients that we're really concerned about is mineral excretion. And I'm sure if you've all heard about the regulations with zinc, as most notably with the EU having regulations in 2022 banning pharmacological levels of zinc oxide use in swine diets. We wanted to dig more into mineral models to predict mineral excretion so that we here in the US have some general understanding of what impacts the excretion of minerals overall. And so we did this through 4 different steps, with the first step being really data collection. And so we followed Prisma flowcharts and guidelines to ultimately identify some variables. And so we utilized a PCA and stepwise selection to pick out what variables most impacted this mineral excretion. We then developed these models and then also validated these models to make sure that they were performing well. Just to break down the data sets that were utilized as part of this meta-regression analysis, a majority of the studies did come from North America. However, we do see lesser of our studies coming from Asia or South America, with an overall 51 published studies being utilized and a total of 620 data points as part of this meta-regression analysis. Now, just to give a quick overview, because we did break these models down into reporting when the pig was fed the minerals under or at the requirement versus over the requirement. And we did this because of the way that the minerals are absorbed based on how they're fed. So if we're under or at the requirement, we'll have a lot of these transporters absorbing the minerals, but we'll also have some of this passive diffusion of zinc as well in the gastrointestinal tract. However, once we get above the animal's requirement, we'll see lesser use of these transporters to essentially bring these minerals into from the digestive tract, and we'll rely more on some of that passive diffusion. This ultimately will help determine some of that excretion into the feces. So to begin breaking down the results from this analysis, I'll start with zinc. And as I had mentioned, we see that the first model we have is at or below the requirement. And what we see is about 61.4% of the excretion is driven by this model or accounted for in this model. And really the main factor was zinc intake. We did see some other factors impact the excretion, such as the type of mineral added or other feed additives. However, really still the main driver was zinc intake. Additionally, we have this other model where we have over the requirement, and we see that the model then accounts for 82.5% of the total fecal zinc excretion. When moving to copper, we see a very similar story, again with 68.4% when we're at or below the requirement. However, that increases to 87.9% when we get over the requirement of copper. Now for iron, we only had 7 data points that were below the NRC requirements. So we ultimately ended up just developing one model since we did not have a robust enough data set to separate that out into 2 separate models. And so we can see that this model accounts for 61.9% of the iron excretion in the feces. Now, when moving on to potassium and sulfur, you'll see that it's a little bit different because these 2 minerals do have significant excretion in the urine as well. So we'll see that this is total excretion. And again, we have just one model. And we'll see with both the potassium and sulfur, we do have fewer data points, especially with the sulfur being more around those extreme ends. And so for these 2 minerals, we definitely would like to see some more research in this area so that we could make these models even more robust. But ultimately for potassium, we see about 80.4%, where for sulfur, we see 57.7%. Now, when you're thinking about the data I just presented on the models, it might seem fairly straightforward, right? So we have this intake of the mineral and we get this linear increase in the excretion. And so it might seem intuitive that some of these regulations limiting feeding of minerals to the requirement of the pig seem logical to help reduce some of this excretion. However, actually, as part of this analysis, we see that it actually can be a little bit more complicated than that. So there is a time component, at least when we're specifically focused on zinc in this case, to where when a pig is weaned, we see that they actually don't initially have a huge excretion of zinc in the feces. Actually, we don't see an increase in that excretion till about day 7 to day 10, to where then we begin to see that linear increase in excretion as we have an increase of zinc in the diet. So this does complicate things a little bit and maybe changes how we view feeding minerals in the diet. Maybe there's a potential that we can feed pharmacological levels of zinc during the early nursery period to help manage things such as post-weaning diarrhea, and then reduce back down to the pig's requirement closer to day 7 to 10 before they begin excreting a lot of that mineral into the feces. And so this is an area that we're hoping to look into some more and continue researching so that we can provide the best data and strategies forward when managing mineral feeding in swine diets. So for the conclusions of this part of the mineral excretion, we see that we do have models that can help account for zinc, copper, and iron excretion, as well as potassium and sulfur, even though we do need some more research on that area. However, we really want to focus on validating some of that time component aspect of mineral excretion, especially as that can maybe influence some of these regulations coming down the line. And so I wanted to thank both of our students who conducted this research, Aran Navalis and then Julian Aragave, who conducted the mineral excretion research, as well as thank the team at Kansas State University, as well as all the collaborators that you saw that has made this project possible as part of the LCA project.